our last class, we have discussed about counter and comparators, right? On this, I'll show one small program like if we are having a parking lot, okay, where we have to park some 10 cars, okay, and there is an in gate and one out gate, right? The number of cars entering from in gate that we have to count up, whereas number of cars going out, we have to count -1, right? So then we are calculating the number of cars present in the parking, right? So for that, we have some indicators at the front gate like uh, red lamp, yellow lamp, and green lamp. The condition is like if zero cars in the parking, if zero cars in the parking, then yellow lamp should be on. If it is 1 to 9, okay, 1 to 9 cars are there in the parking, then green lamp should be on. And 10 cars in the parking, then red lamp should be on. Okay, that which is like parking is full. Okay, so what we are doing here is let's take this switch here. So there is a sensor at the inlet. Okay, and one more sensor at the outlet. Okay, there are two sensors. One is for counter, and the one is for countdown. Countdown means at the outlet. Okay, so here. Uh, C2D for countdown. Okay, how many cars? Like 10 cars. So I'll set the pieces are just 10 cars. I'll set it as. And I'm using the same memory address here, C5 colon 0 for up counter and down counter. Okay, same counter number. Because in same memory we have to increment and decrement. Okay, so for that I'm using limit for 1 to 9 cars. The limit is 1, time limit is 9. Okay, so I just change this word description to 1 to 9 should be green lamp. Okay, green lamp as is equal to 0, then yellow lamp copy and paste. Okay, that is equal to how many? 10 cars, then red lamp should be on. Okay, so there are three outputs, three lamps, three inputs. Okay, one is optional to reset your counter. Okay, that's the condition. Number. Then now, right now, which output is on? Yellow lamp is on because the value in your counter is 0. Okay, now when I start counting, toggle bits 1, you can see green lamp is on. Okay, until when it will be on? Up to 9. Okay, so just click on reading here. 8, and 9. So when it is become 10, you can see green lamp is off and the red lamp is on. Okay? This way we can use this counter and comparator. When the red lamp is on, if any car is leaving, then again green lamp will be on. So that we can enter, okay, from engage. So like that, we can control this parking area, and we can display the number also at by using some number display option. Okay. Now this is one example. We see one more example here using counter and comparator, and one more option, that is latch and latch outputs. Okay. So say I'm having three motors. Okay, there are three motors and there are three inputs. One input is for selecting. Okay, which motor I want to make on, that I can select. Okay, one switch is for selecting the motor. So by selection switch, like one time if I select, I'm selecting say first motor. Okay, and then I give start command, so motor one should be on. It should remain on, hold. Same start stop is there for all the three motors, but we have to select and start and stop. So if I want to start second motor, I will give two counts. Okay, from beginning again, 1 and 2 by selecting selector switch. Again, I give two counts. It will count two times, and then I give start. Motor 2 is starting. It will be on hold. Okay, it will be on condition. Now, two motors are on. If I want to start third motor, same way I have to start from the beginning, 1, 2, 3. Then I will start. Then only motor 3 should be on. Similarly for stopping the motors. If I want to stop second motor first, I'll select 1, 2 count, then give stop. Then the motor should be off. Okay. That way I can start and stop. So here we use selection switch. We can counter. Okay. And preset value, you can give any value like 4, 5, anything. LIM and take PQ. Source A. That is equal to 1. Okay. That is equal to 1. Then I give start command, and instead of this, we'll use latching output. Okay. Not this output, we use latching output. And rename this as motor. Similarly, this is your start input. Okay. So when the value in AC means when accumulator is becoming 1, then this condition will be true, right? When I give the start command, it will give signal to the latch instruction. So it will be holding. Okay. So even if you make this off, this will be on hold because it is a latching point. Okay. It is latched here itself at the output. So at the output coordinate. Now the same condition for stopping, right? We have to stop the output also. So I'll take one input here and one more latching output. Okay. So what we have to latch, unlatch, same output we have to unlatch. Then okay, so you start one, stop. Okay. So I just rename this to start and one stop. Okay. So let's copy paste. Okay. So here we have to just change the value like 2. that is equal to 2 and 3. Okay, when it is equal to 2, then motor 2 should start. So I'll change the output to 2. Here also 2. Input address will be same start stop. Okay, and I change the name of motor 2. Similarly, that is equal to 3, then we have to start our motor. Now, when you give start and stop, this will be setting and resetting. But whenever you give start or stop command, whenever you give start or stop command, your counter should reset. Okay, your counter 0 should reset. So that I can again count from the beginning and select the motor and start or stop. Okay, so that example. Now, what's the value right now? 0, right? So I give one selection, with one value is there. Now, when I give start command, the motor 1 is on, right? And if I read this, the motor 1 is still hold, okay, on. Now, you can see admitter value is reset to 0 because we are given start stop to reset your counter also, right? Whenever you press start or stop, the counter should reset. Okay, in the last we have to give. Now, don't give that start stop here, okay? Because your PLC is executing uh, the logics from top to bottom, left to right order. Okay, so that is the next step, not the so last step. Okay, to reset the counter, not the beginning step, right? So we have to write that in the last step. Now I have counted two value here. So like you toggle bit for start. It will not start here. So when I just count again, 1, 2. Okay, so motor 2 is on. Next, 1, 2, 3. Okay, motor 3 is also on. Okay. Now to stop these motors, right? If I want to stop motor 2 first, I can count 2 times again. Now counting is selecting the motor and then give stop command here. Anywhere you can give, okay, because same start stop inputs are there. Zero here. Is resetting because stop was on. Yeah. I come here, toggle bit. Comes off 3 pounds. Simulation sometimes it is not executing. motor 3 is off, and motor 2 is off. Okay, so these are we can make logics here using counter. Okay, so we'll see one more example, like packing. Okay, on a packing example, like in one box I want to fill around 5 balls. Okay, so for that we are having two conveyor belts. Okay, two conveyor belts on one belt. Uh, Empty boxes are moving. Okay, to sense that empty box, we are having one sensor. Okay, say sensor one. Okay, and conveyor uh, one belt one is run by motor one. Similarly, for second conveyor, which is run by motor two. Okay, on that second conveyor, we are having some balls. Okay, so what happens here when I give start command? Then having one start and stop button also, push buttons. So when I give start command, the motor one should start, right? On which empty boxes are moving. When this motor one should stop, when the sensor one is sensing, so motor one should stop, right? It should stop immediately. And motor two should start. With the sensor one, motor one should stop, motor two should start, on which balls are moving and falling into the box. Okay. When we are counting, okay, sensor 2 is there to count the number of balls. When it is 5 balls, 5 counts, then motor 2 should stop. Again, motor 1 should start. Okay. So, as I said, we are having start and stop command. Okay. For that, we have to use some latching circuit here. So, start. This is also start and stop. And I take one binary bit memory for latching. Okay. Now, this bit memory, again, I take one, I can do this bit memory and start one motor one. Okay, so I take this motor one here. Motor one we are starting. When this motor one should go off, then take this motor one here and start with memory. Okay, motor one is running. So when this motor should go off, copy this for sensor one. So I just change this to sensor one. When sensor one is on, okay, this motor one should go off. Then when sensor one is on, right, it is making the motor one off and it should start the motor 2. It should start the motor 2. So I close this one. I put this motor 2 here. and this motor 2 should also be on hold. Right. So for this, we have to use one latching circuit. Now, when this motor 2 should go off, when your counter is counting up to 5. Okay. So here, I am using, okay. So this is 4 and sensor 2. Okay. Now, okay. We take one equal to EQU and first 35,000 0 dot ACC emitter is equal to 5. Okay. Then we make one bit address on. Okay. Temporary address we take on here. Okay. This will make this motor to off. So you can see here. So make this off and we should again start this motor one. So here in parallel we can start because we are pressing start only one time. Okay. So same bit we start this motor one. So here, so whenever you press sensor, okay, sensor one is on, then your counter should reset. Okay, whenever sensor one is on, your counter should reset to 0. So that it can again count from the beginning. Okay, now, so download. So then we are just seeing the simple logics here. So how to create it. Now, and it's on, the motor one is on. Okay, now when we give the sensor input on, here or here also you can do. What happened? Motor 2 is on, right? Now, sensor 2 start counting. 1, 2, 3, right? 4. Now, here you see motor 1 is off and motor 2 is running, right? So, when I give, let's call 5, you can see this bit is on, motor 2 is off, and again motor 1 is starting. Okay, then when sensor 1 again senses empty box, what happened? Motor 1 is off, again, or motor value is set to 0, motor 2 is on, right? Again, when we start counting, it sensor 2 up to 5 counts. Okay, again motor 2 is off, motor 1 is on. This will continuously goes on, okay, until you do stop. Okay, it is not resetting because here V3 colon 0 is still on. Okay, for that, the reset command. Okay, then when you do the stop, stop. Otherwise, for stop also you can use, if motor 2 is on running, you should stop this motor 2 also. And if you are pressing stop, then your counter should also reset. Okay, it was not resetting, right? So that also you can use one stop. The type here. So you can make a logic. You have to check wherever it is lagging or any input or output you have to add. Okay, that you can check here. Okay, so this is the logic for that conveyor operation. Motor 1 is running conveyor 1. Okay, motor 2 is running conveyor 2. Okay, so